Okay, Satyajit, welcome to YourPedia. Let's start your full
Thank you,
work
sir.
for IIT Delhi. So
Yes,
you start with your introduction.
yes, sir. Sir, I'm Satyajit. I belong to Odisha. I have passed out from Government College of Engineering, Kalahandi in Electrical Engineering in 2020.
Yes. Okay, that's it.
Yes, sir.
Okay, what was your project, final year project?
Sir, my final year project was on optimal placement of a distributed generation unit using particle swarm optimization.
Okay, basically,
Sir, your voice is a bit interrupting.
तो सत्या आपकी आवाज आपका सिग्नल रेड हो रहा है. हेलो.
सर, मेरा सिग्नल रेड हो रहा है. सर, आ रही है क्या?
हेलो. ओके.
Hello, sir.
हाँ, your project was related to the power system, na?
Yes, sir. Power system.
Okay. So what was the objective of that project? Why you did that project?
Sir, the objective, the objective was, in distribution system, we know that R by X ratio is very high. Okay. So we cannot, let's say we are controlling the voltage regulation. So to control the voltage regulation, we need to supply reactive power. Okay. It's not that we can randomly place any generation unit in the distribution network and provide the reactive power. Instead of, improving the voltage regulation, it can deteriorate the voltage regulation. So we need to go for optimization technique to find optimal location. Okay. Hello.
Yes, yes.
Yeah, optimal location and the size of the DG also matters. Means how much reactive power you are going to, inject to the distribution generation unit. So that also.
Okay. Now let me know, how do you decide that optimal location? That
Sir,
will be
there is
that
a
optimal.
Yeah, there is a technique called particle swarm optimization. Okay, that is, basically an optimization technique. So using some constraint, like voltage constraint, current constraint, we are going to implement in MATLAB, and we can, we can decide the location and size of the DG.
Okay, but in practical position, we have the fixed location of generating plants, fixed location of load actually. So
Yeah.
in that scenario, how can we implement such technique?
Sir, practical, they are all generating unit, but we are optimizing the techniques. We are placing distributed generation unit. Like for example, distributed generation unit consists of solar panel, okay, windmill, or any local generating unit. They can be considered as the distributed generation unit. So we have the full freedom to place it anywhere as we want. Okay, that's what.
In last 2 years, in 2020, you did your B.Tech in 2020.
Yes,
so
sir.
Last year, आपने क्या किया? What you did in last 2 years?
Sir, I kept preparing for GATE.
GATE.
Yes, sir.
What are your favorite subjects?
Sir, basically my favorite subject is power electronics, network theory, and I'm also comfortable with control system, signal system also.
Power electronics, you're one of the favorite subjects.
Sir, rectifier and DC-DC converter, like such, and harmonic elements, that is also.
Okay, how we can increase the input power factor in rectifier circuit?
So basically, to improve the input power factor, we need to to increase the input power factor.
हाँ.
So to increase the input power factor, we need to determine that the average voltage should be, I mean, there should be less ripple in the average output voltage. Okay, so that our harmonic can be eliminated, and we can by this way we can improve the input power factor.
Okay. How can we increase the ripple or decrease the ripple?
Sir, there are techniques like using ripple inductor, not ripple, blocking inductor, okay, using a capacitor also, so that voltage can be, voltage ripple can be minimized.
Achha, we have a full wave rectifier and we have full wave, half wave rectifier. Which one we are having the better power factor input?
Input power factor. Sir, in my point of view, full wave rectifier will have the better power factor.
Okay. अच्छा, एक 3 फेज सर्किट में जो और भी होता है, एक 12 पॉइंट होता है, एक 6 पॉइंट होता है 30 डिग्री की डिस्प्लेसमेंट में, उनमें पावर फैक्टर कैसे इंक्रीज होता है?
सर उसके बारे में 12 पावर फैक्टर, उसके बारे में सर मुझे ज्यादा आइडिया नहीं है. सर यूजुअली कैपेसिटर यूज करके भी पावर फैक्टर को इम्प्रूव कर सकते हैं. वैसे भी सर 3 फेज रेक्टिफायर में हार्मोनिक कंटेंट कंपेयर्ड टू सिंगल फेज. हेलो,
वी हैव ए हाफ वेव रेक्टिफायर विद प्योरली इंडक्टिव लोड.
सर माय वॉइस इज क्लियर ना?
यस यस, we have a half wave rectifier with purely inductive load.
Half wave rectifier with purely inductive. Okay.
तो draw the क्या बोलते हैं output voltage curve.
Yes sir. Using sir diode based rectifier or thyristor based rectifier?
कोई सा भी ले लो.
Okay sir, I'm using thyristor based rectifier. Sir, sir, can you look at it?
Yes.
Yeah. So this point is alpha, and this point, the ending current point is pi minus alpha.
So that the voltage curve you have made, na?
Yeah. First one is voltage curve, and second one is current curve.
For the output.
Okay. For the output. Sir, like this. I mean, this will end. I mean, this will follow this waveform, sir. There is mistake.
चलो, ठीक है. Now, Chandra sir will take. Okay, Chandra sir, over to you.
Thank you, sir. Hello, Satyajit. How are you?
Good afternoon, sir.
Good afternoon.
Sir, I'm fine. How are you doing?
Fine, fine. Thank you, thank you. So, your favorite subjects are power electronics, power systems, control systems, and signal systems, right?
Sir, power system. I'm not comfortable with power system.
Okay.
You can ask me questions from control system and somewhat signal system also, power electronics.
But your B.Tech project is related to power system completely. So how
Yes,
can
sir.
you justify this then?
Actually, sir, my for initial B.Tech project was on power electronics. Okay, so to design and implement a 4-quadrant chopper. But my guide that time he got selected in BHEL, so he left the organization. So we were stopped at that time. So we had to go for another project, that is this related to power system. But my initial project was on power electronics only.
Okay, okay. So what is the input power factor of a single phase diode rectifier?
Sir, I mean value or
Formula.
you're talking about?
Value or formula, whatever it is.
Formula. Sir, I need to derive.
Pure resistive load. With pure resistive load.
Okay. So, VM is square. Sir, 2 by pi square.
2 by?
2 by pi square.
Pi square. Is it equal to 1 or less than 1?
Sir, definitely it is going to be less than 1.
So we are taking AC voltage source, a diode and resistance, purely resistive load we are taking.
Yes, sir.
Why the power factor is less than 1 then? Power factor. What is the cause for this power factor to be less than 1?
So the thing is, there are harmonics present in the power factor. Power factor deterioration. The reason is harmonics are present in the the output wave. Okay, because of as we know that from Parseval relation, active power will be carried by single fundamental voltage and fundamental current. But here the input current is going to contain fundamental component as well as the harmonic component also. Okay. So because of the harmonics component, no active power will be carried. Only the fundamental current is going to carry the active power. But those harmonics present in the input current, they are going to deteriorate the power factor because average power is going to be 0 because of them.
What is the difference between an energy signal and power signal?
Sir, energy signal is the power is going to be the power is going to be 0, and for power signal, power is finite, energy is infinite.
Okay, so you just given the definition. Being an electrical engineer, we always write V of t, I of t like that. So those signals are what signals? Suppose those comes under power signals or energy signals. So we are dealing with lots of equations in power systems, electrical machines, and power electronics. So in that perspective, those signals will come under power signal or energy signals.
Sir, we are dealing with all the bounded signals. Okay, bounded in the sense amplitude is bounded with respect to time. So they are all coming under power signal only because their power is always finite.
Power signal means power is always finite and energy is infinite, right?
Yes, sir.
What is your support for that statement? Suppose, imagine I'm asking you as suppose I'm a new student, I'm asking you a question. You are saying that for a power signal, power is infinite, but energy is, so power is finite and energy is infinite. How you are going to prove that?
Sir, do I need to prove mathematically or I will just prove intuitively?
Verbally enough.
Okay.
By taking a very simple example.
Okay. Verbally, for example, I'm taking a sinusoidal wave. Okay. So power is going to be, let's suppose power is going to be Vm sin, voltage signal. Okay. Voltage signal is Vm sin omega t. Okay. So let's say I'm going to take a resistor. So the power
take
is
it as 1 ohm.
Be,
for simplicity, take it as 1 ohm.
Yeah. So the power is going to be RMS value, but I'm representing it as instantaneous value. Okay. So the power is going to be Vm sin omega t ka whole square. Okay. There Vm square sin square omega t. That is the instantaneous power I'm talking about. It is not the average power. So that curve when we plot the curve. Okay. So energy means power into the area of the power is going to give energy. Okay. So when we integrate it with respect to infinite time, I mean with respect to time, so it is going to be infinite, you know?
Okay, fine. What is the difference between a loop and mesh?
Sir, I can't answer.
Okay. What is an independent loop?
Independent loop. Independent loop. Sir, I'm not aware of that.
What is resonance?
Sir, resonance is that condition where even though circuits are consisting of energy storing element like inductor and capacitor, but at some frequency they are going to behave as the circuit is going to behave as a resistive circuit, so that the power factor is going to be unity, and maximum power can be delivered in that circuit at that resonance condition.
So you are giving the definition of resonance with respect to circuits. Suppose I don't know about circuits, then what's your explanation about resonance?
What's my explanation about? I mean, when I'm not going to give a circuit.
Don't take circuit as an example. In general way, what you understood by the term resonance?
Sir, I mean, resonance means maximum utilization of the power. Okay, maximum utilization of the power, and that's how I can define.
Okay. What is power factor and what is the significance of power factor?
So power factor is the fraction of apparent power being used as active power, or we can say useful power. So for example, if I am giving 100 volt ampere as input to a system, so how much power is being utilized as, for example, I'm giving input to a motor. Okay. So out of that 100 volt ampere power, how much power is being utilized or being converted as mechanical power or active power, that can be given by the, I mean, that can be justified by the power factor.
What is the maximum possible value of power factor?
Maximum
possible value of power factor?
Sir, 1 unity.
Is it possible to get any value more than 1?
No, sir. I mean, for passive network or anything, we cannot get.
Okay. Fine. Over to Rajiv, sir.
Okay, Satya.
Yes, sir.
Am I audible?
Good afternoon, sir. Yes, sir.
Am I audible, no?
Yes, sir. You are audible.
Okay, Satya, tell me something. Have you listened to the term modular multi-level converter?
Modular, sir, I have heard about multi-level converter, but I'm not aware of that term, I mean, specific term, modular multi-level converter.
Okay. What is multi-level converter?
Sir, multi-level converter is basically used for used to get highly sinusoidal input. So the basic topology is we are going to connect the converters in cascade. Cascade means in a manner so that we can get highly sinusoidal output from the input.
Okay, Satya. Suppose in the HVDC system,
Yes, sir.
we are having the need of voltage source converter, VSC. Voltage source converter.
Yes, sir. Voltage source converter.
Okay. So how this voltage source converter help in achieving the reduced harmonic effect in the HVDC system?
Sir, voltage source converter is not going to help to get harmonic. I mean reduced harmonic, but Several methods are there from where we can get reduced harmonics by,
Yeah, what?
let's say, yeah, basically PWM technique. One is high frequency PWM, in which sinusoidal PWM comes into picture, and one is low frequency PWM, where voltage switching, like one switching per quarter or two switching per quarter. Such types of techniques are going to come into picture, and they are going to be used to eliminate harmonics from the system.
Okay. There's a term called tuning register.
Tuning register. Okay.
Tuning register.
Okay.
Tuning register and the damping register, they are provided with a shunt capacitor to perform the dual role. Okay, in the harmonic filter.
Okay.
So in the case of BSc, why there is no external capacitor required?
I'm not aware of that, sir.
Okay, you have tell that the method are multi-level converter, right?
Yes.
First,
Yes.
with the help of PWM technique. Okay.
Okay.
What are the advantages related with the PWM technique?
Sir, basically the PWM technique is going to shift the lower order harmonics to higher frequency side, so that they can be easily eliminated using the filter.
And what are the disadvantages of pulse width modulation inverter?
Pulse width modulation, sir, we get less voltage as compared to a normal voltage source, which does not use any PWM technique.
Okay. Having the higher switching loss.
Hello.
Yeah, does the PWM inverters are having the higher switching losses?
Sir, I could not get you. Please repeat again. Your voice is breaking.
Yeah, I have asked, in the PWM inverter, we have
Yeah.
higher switching losses.
Where the higher switching losses?
And for the rectification of these losses, what is the step that we are providing?
Sir, I can't answer about that.
Okay, so Satya.
Yes, sir.
Okay, in which device we are this PWM inverter technique is being used?
PWM technique in which device?
Which device we use in pulse width modulation technique?
Sir, we can use microcontroller, and microcontroller we can use for PWM techniques.
In the PWM technique, switch which we are generally using.
Yeah.
Name the switch.
Switch.
Thyristor.
Sir, basically MOSFETs are going to be used because they can be used for higher frequency operation. Whereas thyristor, that may cause more switching losses. So that's why it is not used for high frequency application.
Okay. Okay. Have you listened the term SMPS, switch mode power supply?
Yes, sir. Switch mode power supply.
Okay, what is this? What is this SMPS?
Sir, SMPS is basically a unit that provides, let's say, it provides the power according to our requirement. Like if supply is let's say 10 volt DC, it can regulate the output voltage at the output and can provide the power accordingly.
Okay, my last question.
Yes, sir.
Okay, we are studying the inverters, right?
Yes, sir. Yes, sir.
Voltage source inverter or current source inverter.
Yes, sir.
Okay. So what is there? Why we are studying the current source inverter and why we are studying the voltage source inverter
Sir,
separately? Why
yeah,
can't these two
I
be
mean,
integrated?
depending on our requirement only, we are studying voltage source inverter and current source inverter. For example, if a device is requiring uh, current, constant current, okay, there should be no interruption in the current. For that, we are using current source inverter. Whereas, uh, if a device requires constant voltage, okay, there should be no fluctuation in the voltage. For that, we are studying the voltage source inverter.
Okay. Does this voltage source inverter
Like
use in the filtering?
voltage source inverter,
Used for filter the harmonic?
sir, inverter may not be used, but some mechanism can be used to filter out the harmonics from voltage source.
Okay, what is the disadvantage of harmonic present in the inverter system?
Sir, harmonics, these harmonics are unuseful components. Like they are actually, because we have fundamental component and harmonic component. Okay, so if a system is having harmonics, okay, from the fundamental component, active power, active power is carried by fundamental component of voltage and fundamental component of current. But if that system is containing harmonics, so they are contributing zero average power in the system. Rather, they are causing
Okay.
the
Okay, Satya.
yeah.
Why there is a feedback required? Feedback diode is required in the current in the voltage source inverter, while it is not required in the current source inverter.
So because current is constant, in voltage source inverter, we have the control over the voltage, but and in current source inverter, we have the control over the current. Okay. So in voltage source inverter, we cannot we cannot control the direction of the current. In which device the current is going to flow, it's not in our hand. But in current source inverter, we have we have the control to to manipulate, to change the direction of current. Okay, and for that only in the the thyristors are not used in voltage source inverter, whereas thyristor can be used in current source inverter.
Okay, Satya, listen.
Yeah.
From the initial question, you were good, but
Yes.
there is some pattern that in some question you try to force your answer.
Okay.
If you know about the concept, then tell. You can either tell it, sir, I can try, but rather to make your question more convinced, you are forcing your answer.
Okay.
Okay. While I ask about the multi-level level converter, the concept
Yeah.
is these techniques are used for filtering, right?
Okay.
These techniques are used for filtering in the modular way, means in the
Okay.
big type of system. Okay,
Okay.
well, I think that you will only concentrate about the converter, about the
Okay.
multi-level converter. Then in the multi-level converter, I've asked some question, but you tried to answer some different one.
Okay.
Okay, so please avoid this type of mistake in the interview. When is the interview?
Okay. Sir, tomorrow only.
Tomorrow only. Okay.
Yeah.
Okay, you have a snap for power electronics in the evening, na?
No, I don't have a snap
Okay, okay.
interview. This was my mock interview.
Actually, I thought someone has already messaged. Okay, no problem. The thing that I have given you the feedback regarding,
Yeah.
yeah, your concept is clear, but in some point you are lagging.
Yeah.
Nevertheless, okay, these type of questions might
Especially,
not. Okay, look, this type of question
especially,
might.
sir, Yeah.
Yeah,
Please tell, sir.
yeah. This type of question might not be asked in the interview,
Yeah.
but in some case, if they ask, then please prepare for this type of question also.
Okay. Sir, in practical, I mean, I'm lagging more in practical
Nothing.
part of the converter. And you asked about how the filtering can be, I mean, how the voltage source converter can be used for filtering. So that I don't know, did not know.
Actually, really, sometimes the professor might ask about the research area where they have seen the new thing, okay, the
Okay.
thing that has been discovered, right? So maybe they will ask,
Yeah.
but they will more concentrate on your syllabus only.
Syllabus only, na?
Yeah.
So, sir, how I can improve the, I mean, how I can improve the quality of my answer? Could you please?
Yeah. See, the thing is that you were good, but um, if you know that there is simple one to make your
Sir,
interviewer
your
works,
voice is,
just